Okay, we'll see how this works. I had one student who couldn't watch the videos. So what I'm going to do is maybe just post the YouTube channel at the top. The only thing is that you're going to have to find your class. And most of the time I say like math something and then the video. So if it's not like that, just let me know. But I just started making videos. They actually take a really long time because I have to process them and then that takes time and it takes time to upload it. So I'm hoping this will save me some time. All right, so how to use hypothesis testing for comparing differences between the mean of two independent populations, two related populations, and the variances of two independent populations. So a lot of terminology, and that's why I'm not giving you a ton of problems, right? Like, they're long, right? How long did we spend, what time is it now? Doing that last problem, like 10 minutes, maybe 15 minutes doing one problem, which to me is, not forever long, but it is longer. So we're gonna do 2 sample tests. What does that mean? That means you're gonna have a sample, say for example, the wait times for a bank for you to be seen by a teller, right? So you have US Bank branch 1 and you have US Bank branch 2, which are, maybe 5 miles apart, and they start taking samples of how long it takes for a customer to be seen by a teller, right? And so they start telling in that information. But let's say you want to compare the two, like how do you know which one has a better or shorter wait time? And that's what we're doing here. So 2 sample tests fall into these 4 categories. Notice that it says not covered in Math 305 and not covered in Math 305. So we are going to cover in the pink population means and independent samples.
The null falls of the non-rejection area.
Yes, these do not fall in the non-rejection area. We will reject them and not cover them in this quarter. And we're gonna cover population variances. Okay. Now variance. So this is just a little bit of a review from Math 130. Variance is VAR, and it is sigma squared. Okay, that's a Greek letter sigma. The standard deviation, right, that we've been seeing so much is just sigma. So the variance is really the standard deviation is just the square root of the variance, right? So that's how these 2 values are related. So in this one, we're going to be comparing basically the standard deviations or some form of the standard deviation. Here we're comparing the population means. Okay, so for the population mean independent samples, there's 3 different cases. For sigma, the standard deviations are known, the standard deviations are unknown, and the standard deviations are unknown and not equal. Okay, and so notice we're going to be comparing the means here and comparing the sample means. So the goal of these tests, test hypothesis or form a confidence interval for the differences between the 2 population means. And so key thing first in all of these is to develop your null hypothesis. But let's go back because apparently I'm missing some things. So what are some examples? The income of men versus women, the price of a product brand 1 versus the price of the product brand 2. So whenever you're seeing these sorts of informations, like how are they comparing things? I think what was one of the things if you took Math 130 with me last quarter, we did a project, and Hassan, you were comparing the income that students were making as they graduated from different Ivy League colleges. So this would actually have been a good test for that, okay? What tests are we going to use? So if we know the standard deviation, we're going to do a z-test. If we do not know the standard deviation for the population, maybe we just know the sample standard deviation, then we're going to do the t-test, okay? One of the questions, I think, for next week is how do you know when you're supposed to use a z-test compared to a t-test? And for both Chapter 9 and both Chapter 10, if you know the standard deviation, then you're going to do the z-test statistic. If it says sample standard deviation, or in this case, the standard deviation is unknown and assumed equal, and unknown and assumed not equal, we're going to do the t-test. And that means we only have some sort of estimate of what we think the standard deviation should be, okay? All right, so what are some assumptions? So this is that question B again. Does it matter what our sample size is? We are assuming in case 1 that all samples are randomly drawn and independent, that we have a normal distribution, okay, and we know the standard deviation. Okay, so here is the equation. You don't have to write this down. What I'm gonna zip a little bit through this, and I'm gonna show you how to do this in Excel, and that's our classwork for today. Okay, I actually don't want you to know how to do this. I want you to know how to do it in Excel, okay? So here is one z value here. Here's how to find the z-test statistic, okay? You can write it down. Maybe that's one of the questions. I have to remind myself of the classwork, but and so this is actually what I want to get to. So you don't actually have to know that formula because I really want you to be able to do it in Excel or StatCrunch, which is kind of cool. StatCrunch costs like $12 for 6 months, and it does everything for you. So we'll spend a little bit of time on that this quarter. I'm not sure if we'll get to it today. But the two-tail test. So the first thing you're going to do in case 1, 2, and 3 is state your null hypothesis. And it doesn't matter what you have, it's always this. Okay? And so what is it saying? The null hypothesis is saying that there is no difference in the means. That the difference between mean 1 and mean 2 is equal to 0. So the null hypothesis, it doesn't matter what problem that you have in case 1, 2, or 3, it's this, that there's no difference between the means. It doesn't mean that that's what we're looking for, but this is always the null hypothesis. The alternative hypothesis says there is sufficient evidence that there is a difference between the two means given. Okay, that's what mu1 minus mu2 is not equal to 0. That's what these things mean right here. Okay? So again, notice the picture. Notice this is our z critical value minus plus. Again, the tails are alpha over 2. And so we reject the null hypothesis if the z-test score that we get with all the values is less than this, if it falls here, or if it's greater than that. That's all this is saying right here. Okay? So again, falls within the non-reject, right? This is the non. Okay. All right. And again, so the confidence interval, I want you to know how to do this. I'm probably not going to make you do this. I'm going to make you find the confidence interval, but we're going to do it in Excel. Okay, so I'm going to just skip through this. The next PowerPoint slide that I'm going to do is just going to show you how to do this. And then we're going to do it together. Okay? All right, so the second case is basically we don't know the standard deviations, but we assume that the standard deviation for the two populations are equal. Why is that important? Because then, notice, I'll show it you. Let's just, all right. Okay, so let's just go in order. So we're going to assume again it's normal distribution. We're going to assume that there's population variances that we do not know them, but we're going to assume that they're equal. Okay. The population variances are assumed equal, so then that way we pull them. That means they are estimated to be the common sigma squared. Okay. And we're going to do the t-test, all right? But our degrees of freedom are now this. So you're going to add the degrees of freedom of your first score. You're going to add the degrees of freedom of your sample, and then you're going to subtract 2. Okay? All right, so pooled variance, I'm not gonna make you, hey, find pooled variance given the data. I won't do that to you, okay? However, I will ask you for the pooled variance, and you're gonna find it through Excel. And now this is all sounding like, oh man, I'm gonna have to know how to do each individual. No, once we set your data and you set your information correctly, and you ask Excel to spit out the information, it'll spit out all of the information for you. Okay, it'll spit out your t-test statistic, it'll spit out your t-critical values, it'll spit out your pooled variance.
The data analysis?
Yes, the data analysis. It'll spit out all of these calculations for you, but the reason why I'm going over them is so that you know what they actually are. Okay, so you're looking at like, oh, what's SP? Like, who cares about that? Well, then if I'm asking for the pooled variance, you'll know that SP is pooled variance. Okay? And what does that mean? It just means because we're assuming that the variances are equal, that we can combine them together. Okay? All right. So again, t-test statistic for case number 2. Right? Notice we're subtracting the sample statistic minus the sample means, and then we pull the variance right here. There's one sample variance, and then we have some variation of the our N1 and N2. Okay? And then again, the confidence interval. But so we're going to get to Excel and it'll show you how to do that. Okay, so let's take a look at a sample. Typically they'll tell us it's, in this case it's telling us that it's case 2. So we have some values here. We have the number, this is N equals. The sample mean is this. And the sample standard deviation is this. Okay? We're going to do case 2. We're going to assume both populations are approximately with equal variances. Is there a difference in the average yields? All right, so what is the null hypothesis for this problem? It's mu. Yeah.
Minus mu2 equals 0.
Yes. And what is the alternative hypothesis?
mu1 minus mu2.
Not equal to 0, right? So what is it saying? That the difference in the mean, there's no difference in the means, and there is a difference in the means. Okay? It doesn't necessarily mean we're looking for the no difference in the means, but that's what the values are. Okay? And so here's all these values. You saw that equation, and here it is plugged in. Okay, so Excel will give you this value, and we're going to probably do this example again together, and it'll spit out this value. I'm just showing you and taking a little bit of time to show you what Excel is actually doing. Okay, and same thing for the pooled variance. I'm not going to make you do this, but this is what Excel is doing for you. Okay. All right, so what is it telling us? Excel gives you all of this information. You wrote your null hypothesis. And so let's take a look at some other values here. We know our alpha is 0.05, right? Does it tell us that? 90%? Okay, no, it tells us our alpha is 0.05. And the question is there a difference in the averages? Okay, that's what it's asking us. And so it tells us our alpha is 0.05. Our degrees of freedom, this is N1 plus N2, which is 21 plus 25, which is 46, minus 2. So our official degrees of freedom is 44. All right, so let's, you can go into your what is it telling us? 2.0154. So again, if it's 0.05, right, you split it in two. And so you're looking at the 97.5 tail in the appendix E3. So 44 is, just look this up in the table. Okay, you find this in the table. Oops. Find this in the T table. And these are our critical values, right? So the non-rejection region is this guy, white space in the middle, correct? And so they give us our t-test statistic, again, by using the equation, and, just as, that's how you do it, but we're going to find it in Excel. So 2.040, does it fall within the non-rejection region?
Outside.
It falls outside the non-rejection region. So our decision is that we reject the null hypothesis at alpha equals 0.05. And the conclusion is there's evidence of a difference in means. Okay, so all of the steps kind of have to happen, even though we're doing it in Excel.
The decision.
Regarding our conclusion, we have to reinstate also our decision as well.
Yes. Yes. Okay, so that's kind of the case 2 is what you're going to see a lot of. Now I just want to show you case 3. Big thing is that we do not have a pooled variance, right? So the equation is a little bit crazier. Here's the t-test statistic. Okay. Ooh, f-test statistic. Do I want to do this real quick? All right, I'm going to stop here, and I'm going to show you how to do this in Excel. So let us, here it is. Okay, so if you haven't done it yet, in week 3, your class assignment, there is a Excel file, and you need to just open that up. Okay, so there's some data here, and we're going to get to that in a second. 9, all right, here. Okay, so we're going to go all the way back to chapter 9, and as we go through the class, you're going to add on to this Excel file. So, using Excel to calculate the confidence values, and so here is the formula. But what you need is the alpha value, you need the population standard deviation, and you need the n value. So if you pull up here, we're going to do a few things, and you have to just kind of follow along with me. So do you guys have Excel? Are you guys ready to open it up? Okay, ready to go. You can do it in Google Sheets. It's not my favorite. Okay, it'll give you weird stuff, but so we're going to open up a sheet on the bottom. We're going to rename this chapter 9. Okay? And so, what do I have here? Oh, there's so many things. I'm going to close all the windows. And what is this? Okay. And we're just going to open, where'd it go?
We're gonna copy something from PowerPoint to Excel.
1 second. I just want to show you, we're going to do some functions all the way through. Okay, so n equals 50, u equals 12. Okay. All right, so we're going to do n is equal to 50. We're going to do, we'll call it mu equals, what is it again? Shucks. 12,000. Oops, no. 12,000. Oh, dear. Alpha equals 5%. Population.
That's for sheet 2, right?
Yes, hold on 1 second.
Yeah, alpha equals 5%.
Yes. Ooh.
The confidence is 95, right?
Yes. Alpha is 0.05. Our x is equal to 1,000. And yeah. No, sorry.
Oh,
Why do I keep going over there? Standard deviation, call it SD, is equal to 1,000. And then, so our average sale price is 12 and the population average is 15. So I keep going to the wrong thing. X is equal to 12,000 and mu is equal to 15,000. Okay. Let me make it bigger. Okay. All right. So here's a data set. Here's some information. And so all we're going to type in is equals. So notice that equal sign. Have to do that. Okay. So we're going to find equals confidence. So notice it's here. You can click on it. It's going to give us the confidence interval, okay? What does it want? It wants the alpha, which is this. It wants the standard deviation, which is this. And it wants the size, which is this. Notice I'm not putting in the numbers. You can put in the numbers. I like to list everything so that in the case that I need to change it, it'll automatically change those values for me. Okay. All right. So let's see if it came out to be the same thing. Actually, don't know if it is. All right. So the value that you should have gotten was 277.
Can you do it one more time? I think I just missed it. What's that? So how did you is equal to confidence and what data? P3, P2.
So alpha, and it has to be, and it tells you right here. See, do you see this under here? There's like a little thing under here. It tells you alpha, standard deviation, and the size.
You're getting this information from what slide? Chapter 10. You're getting this from chapter 10. What slide?
It's not in any of the slides.
Oh.
I mean, it's this one, but it's just, yeah. In the slide, they put the actual numbers, and I created a table and using Excel. So it's not quite the same as the slide.
27. What's that? 277.
Oh, yeah, sorry. Okay. And so this is just the interval, right? Okay, so in this case, let's do x is equal to, our sample mean is 12,000, right? Plus this value, and you hit enter. And our sample mean here, the lower end is 12,000 minus this value. Okay? Is that right? I don't think that's quite right. Nope. X is greater than, okay. I think that's right. Okay. Anyways, so this is the confidence interval. I think that's right. Yes. Okay, cool. All right, so I just did it in Excel. So it's 12,000 plus or minus 277.18. And so the lower level is 11,722, and the upper level is 12,277, which means that because the population average 15,000 is not a part of the interval, we reject the null hypothesis. Okay? So this was just using, this is all the way back to chapter 9. All right? Right. Questions? Did everybody try it
I
somewhere?
didn't get it.
You don't have what? The internet? Do you not have Excel on your computer, or are you doing Excel online? Okay. So everybody's going to need some form of Excel in
Yeah.
this class.
Can you just go on Excel again?
Okay, yes.
And I'll just click on the formula that you use for confidence interval.
This?
Below.
This?
You just wrote it down, this thing?
Yeah.
Minus B6, and over there you
Yeah.
added B6, right?
I mean, I guess I could do here. Why don't I do this? This might actually be better. And so then what happens is what is it doing? It's subtracting this minus this. And let me do that here too. Okay. Questions? All right. So that's that was for finding the confidence interval. All right. I guess I'll do this one. All right. So what if you need to find the T critical values? So instead of looking them up on that table, because you're like, oh, I can't find the right table, or I don't have my book, you can actually have Excel do it for you. Okay? And so why don't we open up a new tab? Okay? I like to just do it like this, because then, yeah. And then when you're looking at it, you're not trying to like, oh, what was this for? Like everything's labeled. Okay, let's again make this bigger. Okay? And so using Excel to find the T critical values. So it's TINV, okay? And notice it just needs the alpha value and the degrees of freedom, okay? So we're gonna do let's do a couple of them. And again, Excel is assuming that you're doing a two-tailed test, okay? So let's do, we'll do the one that they do in Excel, and then we'll do a couple of other ones, right? So finding T critical is equal to TINV, right? Notice here is the, right? So we want the probability, which is 0.05, correct? And we'll do 24. Okay, is that what they do in the thing? I think so. All right, so 2.06. Ooh, let's do this here, actually. Let's do X and B, T, critical. Okay, and this is for, why don't I do this here? Why don't I put alpha and, let's do this. Alpha and, what's the other thing that we need? Degrees of freedom, okay? And so alpha in this case was 0.05, and the degrees of freedom, I'm going to do this. I'm going to do, in this case, let me do this. Oops, sorry. Hold on. Before I do this, let's do this. N, we're going to say this is 25. Okay? So the degrees of freedom is equal to 25 minus 1, right? And why do I want to do that? Because let's say now that we have some values, right? So now it's always going to give me, let's say the degrees of freedom is 64. The degrees of freedom is 50. The degrees of freedom is 8, 30, and 100. Okay, so Excel really kind of helps you out if you know how to set it up right. Okay, let's double check this really quick. So 95% confidence level. Alpha is 2.5. Okay. All right, we're going to do that. So let's do some different, let's keep alpha the same. So what I'm doing here is, you see how it goes to that little arrow in the corner? And if I drop it down, it's just going to give it all the same thing. And the same thing for here, because I dropped it down, it's recreating the equation in for it, okay? That's what's happening. So let's find the T critical value. So for this one, I'm going to rewrite it so that it's this value here. Ooh, shucks. Okay, so let's try this again. Okay, we won't do it. Okay, hold on. Erase this. It's equal to TIMV, parentheses. I'm going to do the alpha now and the degrees of free. Oh, shucks. Sorry. Hold on. TIMV. All right. Alpha. No equal sign. Equals. All right. Click on that. Comma. Sorry. That's what you need is a comma and close the parentheses. Okay. So there's our T critical value. And so because the formula is already there, I should be able to drop this all the way down. And so look, there's all of our T critical values. You do not need the table. Okay? Finding T critical. Oh, let's do this. Let's call this T critical. Okay? All right, so let's open up another one. And now we're going to go to data analysis. Okay? So we're going to get the confidence interval for the mean with t-scores. We're supposing that we have a 95% confidence interval. I do believe there is data already set here. And so why don't we rename this as data, okay, for t-scores, okay? Is this the right one? I can't remember. costs, calories. Yeah. Let's do these ones. Okay. So what we're going to do now is we're going to have the data analysis do a ton of stuff for us. So we're going to go to data, go to data analysis. So t-test, assuming equal variances, right? Wait, actually I don't remember. What are we doing? Sample data, interval, cost per calories, descriptive statistics. Oh, sorry. Forget I said that. Descriptive statistics. We will get to this t-test, but let's start from the beginning. So descriptive statistics. So everybody able to find that? Okay.
I think we have this on the Excel.
Okay, so if you do not have it, what you need to do is you need to go to Excel options and add it on.
I got that
I'm
data.
using the online version, but I don't think I can find this one.
Okay. You have it on there right now?
Yeah.
Okay.
No. So the first one, you just change the name. The import is alright. You just name
Is there any way you can download it into your see how it says open in Excel? Can you download?
I think it's gonna open.
I'm not nervous. Because I think that
I'll have to download it.
no, I'm seeing. Click on that right there. I'll see if I can find it in Excel online. But for those of you, if this is your first time using Excel, you're going to come here to Excel options and go to add-ins and go to, on the bottom, go to go here. And you want to just add the analysis toolpath. And that's what you kind of need here. So we're going to go to data analysis, descriptive statistics, and hit OK. We're going to hit the input range. We're going to highlight both of them. Labels in the first row. Let's just keep the output range here. Oh, wow, what happened here? Okay. Labels in the first row.
Sorry, the data analysis, what did you choose? Descriptive statistics?
Yes. Okay. I highlighted both the local and the chain. I clicked on the labels in the first row, so I highlighted everything. The local, chain, all of this. You're going to click on the summary statistics and confidence level for the mean.
I can't see what's the output.
I just
cannot
clicked
see
on a
that
value.
here. I think you need to move with this a little bit. What's the value that you selected, like overall?
This, I copied both rows. Columns, sorry. Both columns. I highlighted the whole thing. It's highlighted there.
Oh.
Yeah.
Did you?
Yeah, I just clicked on a box anywhere. If you,
Just where you want to go, right?
yeah. You can click on new worksheet if you want to. I just like to see it when I'm there.
And what was the thing that you selected from data analysis? Two circle?
No. Descriptive statistics.
Yeah.
That's it.
Yes.
Select
Oh.
And hit OK. You should spit out a couple of things, right?
Yeah. But the mode is not applicable.
But I'm not getting the ones that you got the options like summary statistics and all that.
Descriptive statistics.
I did that. You went to data analysis and you did descriptive statistic, okay?
Oh, this.
Yeah, these options I'm not seeing.
This is an old version. Are you on Google Sheets?
No, I'm in Excel. I have the latest Excel.
I have the latest Excel on my computer, but I'm using this old one. There
Uh,
should be
so-
some option.
So you just, after this, you selected the data, and I see the output range.
Yeah, just anywhere next to where you're at. Is there another tab for you to be able to do that? You want to show it to me?
Yeah.
Okay.
So this is the descriptive.
Oh, that's it. Summary statistics.
No, the confidence, confidence and all that,
It's right there.
and
That's it.
okay, that's it.
There you go. All right. So, what do you have here? You have the mean for each of them. You have the median. Apparently, there's no mode, probably because in the local, none of them are the same. The mode is just like repeating itself. The standard deviation, the sample variance, which is just the standard deviation squared. And notice you have the confidence level here, down at the bottom. Okay? So you would take the mean, the confidence interval then would be the mean plus or minus this value.
Sorry, the what?
The confidence interval would be the mean plus or minus this value. Right? When you were finding the confidence interval, right, it just gave you like some value and you had to do plus or minus for here. Was it this one? Right? So the number that the confidence interval, that's this guy right here. Right?
So now I'm kind of confused. So
Plus and minus mean, right? Confidence interval plus minus
Yes.
mean. So
so it's mean minus this level.
Yeah, this is just, so it's telling you this plus or minus 2.21, right? And so that'll give you what, 18 less than x is less than 16.7, I don't know, 14. So this is our confidence interval. Okay? This guy right here is the same thing that we found here.
Why the Excel doesn't allow us to already select this,
What do you mean?
the confidence interval?
Oh, it will, but it's not there yet. It'll give it to us. Yeah. All right. So this is for a different set of data, right? And we click to make sure you click 95% margin or in confidence. But if it's 90%, put in 90%, right? So notice this is the information that it gave you. This right here is the confidence level. So you would take 191 plus 5.4 and 191 minus 5.4. And that would be your confidence interval. Okay? All right. So the lower limit's 185.55, the upper limit's 196.45, just like what I was showing you a minute ago. All right, so chapter 10, what we talked about in class, like just a minute ago when I was lecturing, that's what we're going to do right now. Okay? Oh, okay. Do you guys have it online? Can you guys pull this up really quick? Should be on your Moodle page.
and just copy this data.
Yeah, just copy it because I thought that I had it in your file and I didn't. So for in your Excel file, under sheet 4, just rename it as chapter 10. Okay, and then you're going to want to do weeks, Walmart, and what is it again? Target. Sorry. Target and Walmart. Okay, and you're going to want to put all of these prices in. So for weeks 1 through 20, and the prices of a house cleaner observed for 21 weeks.
Your Excel file is chapter 9 and 10, so it's in the chapter 10 slide, right?
Chapter 10, yeah. This is chapter 10.
Page 14.
All right, so notice, can you actually write all of these things down? What N1 is equal to, N2, what your null hypothesis.
Is it as a picture on your? Oh, okay. So we have to type it in.
You have to type it in, yeah. In the same Excel file that we opened up, okay?
It's not there in chapter 10.
No. It says chapter 9 and 10 Excel. It's a different Excel file. Are we not finding it?
Yes. In class today you're fine. And then is it class assignment?
Or just do me a favor, and why don't you guys go ahead and just...
I got the PPT, I found it, but let me try to copy it.
Okay. Well, what I was going to tell you to do is just, why don't you read it to me?
Okay.
Hold on.
It's week 1 is 1, 2, 3, 4 till 20. You can just drag it.
Will it do it all the way down?
Yeah.
Yeah, it's 20.
21, right?
No, till 20.
No, see, look, it won't do it.
Because you have to select
Select
like
from the
more than
first
one. If you
one.
select like 4, 5, 6, it continues.
Yeah, now it did.
Oh, there it is. Okay.
And the target is 8, 5, 6, 7.
2, 5, 6, 7.
Like
8,
that?
8, 6, 3.
Oh, shucks. Hold on.
1,
8,
8,
8.
6,
Uh-huh.
3, 5,
Uh-huh.
6, 8, 6, 4,
Mm-hmm.
7,
Mm-hmm.
7, 7, 8, 9, 5, 5.
Okay. And what about Walmart?
7, 6, 8, 8, 8, 4, 4, 4, 5, 5, 6, 5, 4, 8, 7, 5, 6, 5, 4, 4.
Is this right?
Yeah.
Okay. I will make it bigger. Maybe not that big. Oh. Sorry. A little smaller. Okay. Can you guys see it? Sorry.
Let me copy.
And so the null, so n of target is what? I think they have different n's, right? Okay, so you just can't see it, but so
Target.
yeah, see, you just can't see the different prices, but N of Walmart is 21. And then so the H naught is equal to U1 is equal to U2. You can do that, or you can do this, right? So they both mean the same thing. U1 minus U2 is equal to 0. Either one is correct. H1, right, is equal to U1 equals not equal to U2, right? That's our null hypothesis. Okay, or you could just write not equal. That makes sense. Okay. All right. So what are we going to do now? We are going to go enter data analysis, Z test for 2 sample means. So we're going to do case 1. Okay, we're going to do case 1, case 2, case 3. Right? I don't know if we get to any more than that. But so notice, select the data range for both variables by clicking the red arrows, then enter 0 for a hypothesized mean difference. Enter the variance for sample 1 and sample 2, then enter the alpha of 0.05 and then click OK. All right? Enter the variance. Do they give it to us? Known variance. Okay, so I'm just going to give you so here just look for the known variance, and then for Target is 2 and Walmart is 3. So let's go back to here, go back to data analysis. We are going to do the Z test. Ooh. Paired sample for the mean. Does it say Z test? Oh, what do I do now? It doesn't say it here. Okay, maybe sample means. So you're going to do the T test for 2 sample means, okay? So variable range 1. Variable range 2. The labels, we included the labels. What's the hypothesized mean difference? Should be 0. Okay? So you don't have to put the variances in. The output range, I'm just going to put it right here. Okay? Questions? So variable range 1 is this first column. Variable range 2 is the second column. I included the labels. I gave our alpha, and the hypothesized mean difference is 0. So everybody got that? What do you have? We're not even here yet? So we're going to do T test for the sample means. Okay, so I'm going to put this out, but then go back to data analysis. It's the T test for paired 2 sample means. Okay? And so then once you click on that,
write it down these like on the Excel, right? Just to remember.
That's what's, it's just not as like clear cut. Yeah.
Okay, so here's the range 1. Range 1 is going to be target.
Yes.
I just missed like what else did you use?
Okay, so the first row is Target, the second row is Walmart, and highlight everything, Target down to the last number.
Yeah, and that's it?
Yes.
You don't put labels?
No, so then you're going to click on labels because you highlighted Target, right? Hold on, let's just do it again. Labels, alpha is 0.05. Here, I'll just leave it up there. Can you see it?
Okay. And then anywhere on that.
We're going to get slightly different values because we didn't have 21 for Walmart, right? And 20 for Target, but that's okay. Yeah, this it doesn't show the Z test. I'm actually tempted to look.
It shows right there, like in the title of the.
Oh yeah. So we're going to have slightly different values, okay, than what this is because we do. And so notice our mean, we have different variances. Don't worry about this Pearson correlation, but notice the hypothesized mean difference is 0. Notice our degrees of freedom, right? It's 20 plus 20 minus 2. Wait. Oh, I wonder why it did that.
It's 20 minus 1.
Yeah, you know what? It should be a z-test. That one's, does it give you a z-test? And my computer's right here. Hold on. So why don't we do this really quick? Come here to StatCrunch.
StatCrunch.
Yeah. I don't know what my ID is. I can't remember.
So what I use for your password?
Hold on 1 second. I don't know what my password is. I'm trying to remember. Okay, it's on my computer. Anyways, it's okay. For some reason, it's not giving us the z-test, and that's actually what I want. For your analysis.
But on the data analysis, like right on the end, z-test, choose samples.
Oh!
Right?
Yeah, I didn't see it. I'm sorry. That's actually what we wanted. Did you guys pick the t-test? I'm sorry. I didn't even see it.
No, now I found it.
Okay, so we're going to do, sorry, here. Let's do this again. Target. I was wondering why we were missing something. Okay. Highlight it. Hypothesize mean difference is 0. Variable, this should be 2. This should be 3. Labels. And we're going to just click it right here. Okay.
Okay, so why did you use variance 1
Yes.
as 2 and variance 2 as 3?
They should have given it to you in the thing, but it just, yeah. So it was supposed to be given. Okay? All right, so sorry about that. I was like, oh, why didn't they have z-tests? So we're doing the z-test. We're doing case 1. And so notice our z-critical is plus or minus 1.959. Our z-score is 1.5. Okay? And
Can you
so...
just do the z part again? I just want to see what values we selected.
Oh, okay, I'm sorry.
Yeah,
Here.
it was really quick.
Yeah. They should give you your known variances.
You went to data analysis and again you selected.
Z-test for 2 sample means. It was all the way at the bottom, but for whatever reason, when I either just didn't see it or I didn't scroll all the way down. This is a z-test for 2 sample means. So this is case 1. And so I don't want you to do all of it like the equations, right? The Excel will do it for you. How are we doing here so far?
Up here too.
The worst part is just like knowing where to apply what.
What do you mean? Oh, like where everything goes?
No, where to apply. Like when you read the PowerPoint, then you go from 0 to this. The Excel part is easy. The worst part is just like the critical thinking.
Oh, like deciding what belongs where. Okay, yes. And that's true.
Everything that we do by ourselves.
Okay, I got
No,
that.
but I mean, if you know what you need, your deviation and all that, you know everything where it comes from.
And
Yeah,
so,
I got it.
When it goes to Excel, it's like
for the most part, the actual Excel part is fine. But yeah, just separating everything out. So let's talk about this. So notice that 1.68 is what we got here, right? 1.
Five.
Oh, how come it's different? Oh, we're probably missing something. All right. So it's okay. We have 1.5. It's still less than 1.96, right? And so we're not going to do not reject the null hypothesis. And we conclude that we are 95% confident that these two samples have the same population mean. Okay, that's your actual answer, right? So you didn't have to do all of the work like we did in the PowerPoint, right? Or even like in chapter 9, there is a little bit more work for that, right? But the final answer, so if you were to just give me this, right? And you didn't if you didn't give me the null hypothesis and you didn't like write everything out and all you did was spit out this thing, I wouldn't give you very many points, right? Because you didn't do anything. So what the whole point of this exercise is, I'm trying to save you from the calculation part, because to me, not that that's not important, but can you interpret what this is saying? And so the key bits of information is this, right? This is your z-test statistic. And then you need to know that you're doing z critical to tail. Okay? That's what we're going to be focusing on. All right?
So can I just see the answer again on the PowerPoint?
It's different.
No, just the
Oh, it's not
statement
the
to write it
same.
down.
I mean,
That's
this
the-
is, yeah, it's not the same. No,
Oh,
because
but
we're
just
missing.
go back as we did in the last class. Do not reject, it will do 95%.
Yes.
because-
Yes. You just need to add that to your Excel file. Okay? All right. So now we're going to do case 2. Under the data analysis, now we're going to do the t-test assuming equal variances. We're going to select the data range for both and enter 0 for hypothesized mean difference. Okay? Let's do it for the same set of data.
Pretty much we already did.
Yes, yeah, and I just wrote over it, so I have to do it again. If you didn't, assuming equal variances. No, we did the t-test for assuming the means. We're going to do a different test, okay? So t-test assuming equal variances. We're doing case 2, okay? T-test assuming equal variances. So again, highlight target. Highlight Walmart. Hypothesize mean difference is always 0. Highlight the labels. And the output range, I'm actually just going to put it below here. Okay? So I'll leave that up for you to look at.
So can you bring the table down and spreading out? Sorry. In the,
Yeah.
What do you
just
mean?
in this below. In this column,
There
yeah,
you
that's
go.
what I asked. So I need to see what you select. You know. That's good.
Did I hit okay?
No, 1 second.
So again, you said we were gonna select just target.
And Walmart. You have to set both of them.
Oh,
Yes. So variable 1 range is target, variable 2 range is Walmart. Hypothesize mean difference should be 0.
Okay, good.
Make sure you click the labels. All right, so now we have this. The mean, the means and the should be the same, right? Notice the variance is different. Notice they're giving you a pooled variance. That was the case for case 2, right? So if I asked you for the pooled variance, this is how you would find it. Notice it's giving you their degrees of freedom. It's 20 plus 20 minus 2, which is 38. Our t-test statistic is 1.5, and our t-critical is plus or minus 2.02. So I'm going to highlight these so you can see that.
See, your observation says 20 and mine just says 19. You guys selected all 20.
You did 2 sample means. You need to do the t-test statistics assuming equal variances.
Oh, okay. Sorry.
Yes. No, I did the same. Well, I originally did that first one because I was looking for the z-test, and I thought that that's what that was, but there was a z-test. It was on the bottom. Okay, so this needs to be t-test 2 sample assuming equal variances.
Yeah.
So because we're missing like one set of data, I think from Walmart, so it's 20 and 20 instead of 20 and 21, it's okay though. Like the idea should still be about the same.
If it's okay, I've got 19 observations then?
No, because you're in the wrong test.
No, I did the, what was that, 2 sample t-test, 2 sample assuming equal variances.
You shouldn't have 19. Your degrees of freedom is 19. Your
No,
DF?
observations and degree of freedom is 36.
Yeah, no,
Can
you
just look
should.
what I'm doing wrong, I'll do it really quick.
Yeah. It's 36 because your observations is 19. Yeah.
So basically I'll just go here. These are my target and
Oh,
Walmart.
okay. So we're going to do this. Hold
Data
on.
analysis is here.
Hold on.
Okay, so
I don't know why this is making a difference, but it is. So do you have, hold on. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12,
That's
17,
from 1 to
18,
20.
19, 20. Okay, yeah. So
Equal, right?
now
Yeah,
let's do
equal
it.
variances.
Oh, equal there.
2 7.
Uh-huh.
So this one is, oh, because you hit labels and you didn't include the label.
Okay,
That's
it
fine.
makes sense now.
Yeah.
You asked me to hit the label, so I did, but I didn't selected the numbers.
Yeah, if
So
you're
I
gonna-
think I should get now.
Yes.
And labels, it's okay. Do it okay. Okay.
Yes. Okay. Yeah.
Just
Um,
a small error.
So real quick, one of the things Akshay highlighted all of this and didn't highlight target, but clicked on labels, and so it assumed that 8 was the label. So make sure if you're going to click on labels, you actually have to highlight target all the way down to the very last variable. Okay? All right, so this is our 2 tests. So what is it saying here? What can we say? Our T statistic is 1.529. Does it fall within or without the non-rejection region? It falls within, right? So we they got 1.71 because they have a slightly different set of values, but we have, what's ours? 1.6? Oh, for the next one. So 1.5 is for the z-test. So now we're on t-test. We're in case 2.
So
T-test for assuming sample.
1.5296.
Yes. Okay. 1.52. So our so we 1.52 is less than 2.02.
Uh-huh.
We do not reject the null hypothesis and conclude that we are 95% confident that these 2 samples have the same population means. Okay? And it should be the same thing, right? Because we're doing the same set of data. All right, so case 3, we're going to do all with the same set of data, 2 test sample assuming unequal variances.
the same, but just select the unequal.
Yeah. So this one right here, if you want to do me a favor and put case 1, this is case 2, and this last one we're going to do is case 3, right? So again, data analysis, t-test assuming unequal variances. Okay, so again, highlight the target, highlight Walmart, hypothesized mean difference is 0, highlight the labels. I'm going to put the output range here, right below it. I'm going to leave that up. I'm not typing it out, but make sure you type out the conclusions
Yeah.
in your Excel. Okay. Can I hit OK, or do you guys need to see this? Okay. It gets easier the more you do it, right?
I wouldn't say easier, but you know.
We're gonna post this video.
Yes.
Yeah, I'm going to put it up. It's going to be long, but you can fast forward.
Not too
So,
less than
this
like
case-
1 hour, 10 minutes.
That's not too bad. All right, I'm going to hit OK. Okay, so again, notice the t-test statistic is the same, right? So our conclusion is our t-stat is less than the t-critical of 2.02. So we conclude that we do not reject the null hypothesis. It should all be the same, right? Because we're doing the same data. We do not reject the null hypothesis, and we are 95% confident that there's no difference in the means, okay? Right? They have the same population means. I am actually, that's not me, right? Okay. So, oh, come here.
How
Yes.
can we make these like from these tables? Can we make the normal distribution like a graphic of normal distribution on Excel?
Oh, like you want to draw a graph?
Yes.
All right. So let's see here. I can't guarantee that it'll happen,
I
but
never seen like the normal distribution. I don't think they have it.
no, they don't. And so this is where I wanted to get into StatCrunch. So I'm going to push pause on this really quick.
Is this the class for you to
Today, because we're in class.